Okay guys, this is a daily video. I've cut it for some other classes and I haven't done it for you guys, but I need to start getting in that habit. Okay, today's Monday, February 10th. This is just me talking to you guys about stuff you can get done here during class. Today I have to do some grant application stuff. I'll be available for your guys' project discussions during 9th period, but not 8th. So when you get here, check out this video. I'll point you to Google Classroom. I've got a lesson here on FEA. I don't know if you guys are done with the Autodesk classes yet, but I'd like you to finish those. We've got some new stuff in here about FEA, plus what I've used it for potentially, or not potentially, what I've used it for in the past. And hopefully we can talk about why it is important for you guys to know. So that's about it. FEA's come a long way. It's been around since the 50s, and the reason why it was invented was basically physicists had to solve huge problems on limited computation power. Like, say, for example, the Apollo central computer for the Apollo program had less computation power than one of your earbuds. Like, no kidding. But you still needed to solve things, to big enough math problems to, say, simulate something as big as a spacecraft. So the FEA was born in the 50s. It's a formulation on Newton's three laws. It's a bunch of matrix math is all it is. Linear algebra. And it's that plus computation theory in order to get the stuff to run on limited hardware. That is no longer a limitation, essentially, but FEA will continue to be important because it is not statistics. It is not AI. It is something else. And for that reason, it's going to be something that's with us going forward. You'll see it in your jobs going forward in place of testing, in place of product testing, virtual submissions of products to companies. At Goodyear, we used to submit virtual tires, just the CAD model, and the virtual tests we would run in FEA. For the first couple of submissions until about the fourth build, we would actually do it for real. So that's one application of it. We use it to simulate the effect of laser eye surgery on how that would affect somebody's sight. So we're actually able to, in an FEA model, simulate the surgery, which is shooting holes in the eye, and how that would change the shape of the lens, and therefore how it refracted light. So all kinds of interesting stuff, but go ahead and check it out when you guys get into class, and we'll talk about it some more. There's some the main packages in there like ANSYS, Abaqus, Fusion 360, Nastran. I talk about a lot of that stuff. So if you could, just go ahead and get busy on it. And if you have anything to talk to me about, 9th period. Thanks, guys.